Hey everybody, this is Larry. This is day 9 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's prompt, 2306, naming a company. Okay, let's kind of take a look at this. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this poem. I'm probably going to, as you can see from the glasses, I'm a little bit later in the day. Went out to get food. If you want to see what food I got, check out that Instagram. I don't know. That's the closest thing I have to an ad on this channel is me kind of trying to show off my pretty pictures from once in a while. Link below. But anyway, let's get started. Naming a company. Okay, so what is this button? That's a very weird ... companies. Okay. Anyway, let me also check real quick, see for points. No extra coins. Anyway, you're given an array of string ideas that represent a list of names that are used in the process of naming a country or a company. The process of naming a company is as follows. Choose two distinct names from ideas A and B, and then swap the first letter of idea A and idea B of each other. If both of these new names are not found in the original ideas, then the name idea A and idea B is a valid company name. Otherwise, it is not a valid name. We return the distinct valid names, a number of distinct valid names for the company. Okay, so first of all, we're going to look at the constraints. 10 characters times 5 to the 10 to the 4th means that we can at least put them in a set. I think that is useful. Yeah, let's do that first, right? So we can kind of do lookups in a quick way. And also I'm not married to this idea. We can change it later, right? Of course, the thing that we have to try to find is something that is linear 5 times 10 to the 4th or linear times log n, or in my case, the thing that I'm going to think about is linear times 26, which is the size of the alphabet, right? And what am I meaning here, right? Meaning that basically given let's see. Let me double check on the understanding of this problem. So first letters of ideas A and ideas B, or idea B, and then if both of the new names are not found, so they have to be different, right? So it's some number times 2, right? By then, because it's we have to swap to them or whatever. Okay, so coffee and donuts is toffee and coconuts. So okay, so I mean I think that's really the I think that's the idea that I have is going to be something like really if for each word like coffee, you can only change the first character 26 times, right? So that's one, and then yeah, so I think that's basically the idea. Is that okay? First of all, we do a count of words and the first characters, right? So maybe we have something like first character is equal to collections dot counter, right? And then maybe for idea and ideas, we have first of idea 0. Maybe I'm not sold on this, right? But which is just to get a count. But then after that, we can say for each word, right? So for each word, what can we do? Well, we can see, how do I phrase this, right? So basically this idea is the first word, right? And then now we're trying the second word in which it is valid. And it is valid if, so for, I don't know, just F in range of 26 or something like this, or in, what's it called? String dot alpha, I forget what it's called, Python alphabet list, right? Or something like this. I forget what it's called, ASCII lowercase? Okay, fine. That's not even close, right? But basically you have then, let's say new idea, and we could maybe do this in a smarter way, but for now let's do it the dumb way, right? And then basically this is the new idea, And if new idea is not in set, then that means that F is a good character, right? And then that means that we can combine that with all the things that are in F. Oh, I see. Because then the idea here is that, for example, if C can, if Dolphy with D, with coffee, and then we have a D, doesn't, that means that we can add a D, right? That means that the second word can be a word beginning with a D. But now we have to check the other thing, where we have to check the number of words where D's, like how many of these words with D can have a C, right? So that's basically the idea. And I think now that I fleshed this idea out a little bit more, then I can say, yeah, if this is not idea, then we can maybe do, instead of first, we can maybe do a mapping now, right? And what I mean by that is going to be a 26 by 26 array, right? So then now, maybe I have something like good is equal to 0 times 26 for 26 or something like this, right? And then now, this means that idea of 0 changing to F is good, right? So that means that we want, oh, whoops, we removed this. So maybe good count of, let's just say, first idea character is equal to idea of 0, and then we want to convert it to a number between 0 and 26. So we have this minus order of A, the character A, which I'm just going to do old A for that reason, right? And then now we just do enumerate. This is a little bit yucky, but that's okay. Maybe this is like a, maybe this is AI for A index, right? So then now that means that there are, yeah, that, and basically what I'm doing here is that good of ij, for characters I and j are characters from A to Z, going to be number of words that are okay with changing from I to J, right? Okay, so I think this now sets it up for us, because now we can just try all 26 square words, right? Or pairing, because now that we bucket them, then now we have for AI in range of 26, for BI in range of 26, then you have, I think maybe BI, right? And the second word has to also be okay with going back to AI. That's the point. So then now, do we have to mod this, or I guess we don't, because it's just this square in the worst case. But this looks very awkward. That's all. And I think that's it, maybe, unless I missed a case. I think AI has to be not equal to BI, but then this should always be 0 if AI is equal to BI. So I think maybe that's okay, but let's take a look. All right, these are really dubious cases, so that does not give me confidence, but I am lazy, so let's give it a submit. Shouldn't time out though. Okay, cool. Wow, apparently I've done this farm. Oh no, it's just once, but maybe I optimized it 3 times or something. Yeah, okay. But yeah, so this is going to be linear times alpha. This is the O of n component, and this is the alpha component. Though you could say that I also did another O of n, or not O of n, but O of 10 for, or L for the length of the idea. Though you could do that in a slightly better way, but probably not that much more, to be frank. Like you could maybe do it in a reverse try or something like this, like counting backwards. Then you only have to go up 1 character instead of all the way through, and that will give you like O of L plus or like O of L per n, which is linear anyway. So there's some optimizations you can do to kind of minimize this part. How was my timing? I forget. I wasn't paying attention. Yeah, so maybe you can optimize that part, but I'm not going to worry that much about it because everything else here is relatively. Oh, I guess I'd use. Yeah. Though this is linear anyway, unless you also implement it using a try, and in this case, I would use a reverse try or something like this. But yeah. So this is O of n, this is O of 26, and this is O of L, and this is O of L, where L is the length of the word, right? And this is obviously 26 square or O of alpha square. So in total, it should be O of n times L times A for alpha plus A square. Oops. And yeah, this is also n times L, but it gets dominated the other part, and this is n square as well, but for space. This is O of n times L space though, so yeah, that's all I have for this one, I think. I don't know if I explained it that well. Let me know in the comments if I didn't. But basically the idea is just calculating, just coming up with this idea of number of words that are okay from I to J, and therefore the second word, because the first word has to go from I to J, and then the second word is going from J to I. That's basically where I get this thing from, and then you just kind of sum it all up for every possibility. And because we do this asymmetrically, yeah, this should be good. I mean, you could also do like AI plus 1 for a minor optimization, something like this, but it doesn't really matter, right? I think this is slightly easier to read, and all the numbers are small enough that you're not running into expensive calculation things. So yeah, that's all I have for this one. Let me know what you think. I am passing out, so not going to do another thing. But yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.